Welcome back. Now we're moving into a new lesson, into 6.3. And in this lesson, we're going to be talking about adding and subtracting radical expressions. So a couple of things to note is in order to combine a radical expression, the radicand has to be the same. Okay, so for example, these are like radicals, so I can take that 1 plus the 3 and say I have 4 of them. Here again, the radicals are the same, so 1 of them minus 5 of them gives me -4 of them. Same thing can happen when you have variables. However, do note that in certain circumstances it doesn't work. So in this case, my radicals are not the same. Okay, I have a 5x and a 6y, so those can't combine. Okay, you need to have the same number inside the radical. That's the only way that you can combine the like radicals. And they have to have the same index. So here, even though the number inside is the same, if the index is different, you can't combine them. So same index and same thing inside the radical. That is what we're looking for in order to combine them. All right. So let's take a look at these quick examples. So 3 square roots of 14 plus a 7 square roots of 14. Well, same index, same number inside the radical, both are 14. So I can just take 3 plus 7. It means I have 10 of them. So notice when I'm adding, all I'm doing is adding the coefficients. I'm not doing anything with what's inside the radical. It's like taking 6x squared plus 5x squared and getting 11x squared. That square doesn't change, it's just the coefficient of them that does. So this shouldn't be anything shocking or any revelation. It's just kind of an extension of what you already know to do with polynomials. So here, square roots of 7. So I start with 2 of them, minus 8. So I have -6 square roots of 7. Now notice this 10, it can't combine with them. It's a different number, okay? It is not a like radical with the other two. So what that means is it doesn't combine with the other two. It stays off separately and will just stay like that. Okay, so don't think everything has to combine. That's not what's going to end up happening here. Okay, some of them are going to have to stay separate. And don't forget, this process even works when you have variables. So they are all three like radicals. They're cubes and all three x's. So 5 plus 4 minus 1. So that's going to leave me with 8 of those cube roots of 3x. Okay, so again, just note this process does continue working even if you have variables on the inside. Now, I'll say those were very basic examples, okay? That would have been the very first thing we showed you back in Expo 2 years ago. Now, the real meat of it is being able to simplify first, okay? If I throw something like this at you, the goal is that you know to simplify the radical, then you can start adding and subtracting them together. So what does that mean? Well, square root of 12. And of course, if you ever need help, refer to your powers chart on how to break it apart. 12 is divisible by 4, okay? So I break that 12 up into 4 and 3. That's 75. Well, again, looking at my chart, 75 can break up using 25. So it breaks up into 25 and 3, and then that 3 doesn't really have to do anything. Okay, that square root of 3, I don't need to pull anything out of it. I know what the square root of 4 is. I know that that's 2. I know the square root of 25 is 5. And then I'm subtracting off another 1. So now that I've reduced it like that, now that I've simplified, the radical, now I can see that all three are like radicals, so all three are going to combine. 2 plus 5 is 7, minus 1 leaves me with 6 of those square roots of 3. And it even works when you're dealing with cubed roots as well. So let's take a look at that. 250. So now if I'm focusing on cubed roots, 250, I think pretty quickly your eyes will be drawn to 125. Okay, 250 divided by 125 leaves you with 2. So that breaks up to 125 and 2. 54. If you're looking at this list, I think probably you've seen that number multiple times now. I think you're probably getting used to the fact it's divisible by 27. So this breaks up into 27 times 2. And then 16, well, 16, I think this 8 would probably draw your attention. 16 is divisible by 8. It'll split up into 8 and 2. Oh, and that should be a minus sign. I'm sorry, I wrote that wrong. That's a minus. So cubed root of 125 is 5. Cubed root of 27 is 3. Cubed root of 8 is 2. So once you simplify the radicals, now you can see all of them are like radicals. So 5 plus 3 is 8, minus 2 leaves me with 6 of those square roots of 2. All right, so before we move on to the next concept, let's take a moment here and talk about an architecture word problem, okay? I do enjoy throwing in some word problems for you so you can see where this kind of stuff can be applied. So in the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. All right, so let's take a look at this. So what I need is the perimeter. So I need these outsides. Okay, so really what I need is of one of those rectangles or of one of these squares, what I need is one of those cross sections. I need one of those diagonals, all right? Because all those lengths around the outside is going to be one of those diagonals. Well, what do I know so far? Well, I know that the side of each square, each side is going to be 5. Okay, I also know this is a right angle. So I'm hoping that you can see back from geometry, how can I find that diagonal? Well, the key is actually in Pythagorean's theorem. Okay, remember, that's how you can find the hypotenuse of a right triangle. A squared plus b squared equals c squared. So I'm actually going to get to apply this. I'm going to get to use Pythagorean's theorem. Because I have 5 squared plus 5 squared, okay, those two legs of the right triangle, and I want to know what is the diagonal piece, what is the hypotenuse. 25 plus 25 is going to be 50. So that diagonal piece is going to be the square root of 50, okay? Now, of course, I'm not going to leave it like that, because as educated Algebra 2 students, we can see that the square root of 50 is actually going to break down. What perfect square divides into 50? Well, 25 and 2. So what does that mean? That means I'm going to have 5 square roots of 2. So each of those little diagonals along the way, each of those diagonals is going to be 5 square roots of 2. Right? And how many of them do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have 10 of those little diagonals. Okay, so I want the perimeter of the window is going to be 10 times that. Okay, so I'm going to have 50 of the square roots of 2. And it says to the nearest inch, or to the nearest tenth of an inch. So if I type that into my calculator, we're going to be talking approximately 70.7 inches. All right, just for a little application for you. So make sure you have that written down, and we're going to move on to our next slide, which involves binomial radicals. So binomial radical expressions. Now, you've seen things like these before. You've seen it with polynomials, and you've seen them with imaginary, or I should say complex numbers. So spoiler alert, I'm sure that you've already noticed, this means that to simplify this, we can actually end up factoring these things, or foiling these things, I apologize. So that's going to be the key. And once it's foiled, then we'll have some radical expressions to add and subtract, okay? But the key is when you see something like this, your instinct should be to foil, okay? That should be the first thing that you want to do. So 1 times 2 is 2. 1 times square root of 5, 2 times the square root of 5. Now square root of 5 times square root of 5. So that is the square root of 25, or just the number 5. So remember, if you have a radical times itself, it just gives back whatever it was, or you can go through the process of thinking, square root of 5 times square root of 5, okay, that's the square root of 25. Square root of 25 is 5. Whichever way helps you, okay, whichever way makes the most sense to you, just be able to get that number 5 as the last thing. And now the skill we were just working on comes into play. Now I'm going to start adding and subtracting like radicals. 2 plus 5 gives me 7. 1 square root of 5 plus 2 square root of 5 is 3 square roots of 5. And that's how I'm going to leave my answer. That's what I want my answers to these to look like, okay? I want them to just look like a binomial radical. I want to get rid of that multiplication piece. So let's do another example. Again, let's FOIL this out. 2 times 5 gives me 10, minus 2 square roots of 2, plus 5 square roots of 3, minus, now both of those things are inside the radical, so I'm going to multiply those numbers and leave them inside the radical, right? Remember, you can't mix and match, so you can multiply two things outside of a radical and two things inside of a radical, but you can't mix and match. So make sure that you know exactly where each of those pieces came from. Again, because you cannot mix and match. Things outside have to stay separate from the things inside. And now if you actually look through this, none of those things actually end up being like terms. So that means in this instance, I'm actually already done because nothing is going to end up being simplified. So let's move on to our next one. So 5 times 2 is 10. They're going to multiply the things on the outside, but the square root of 7 has to stay separate. Here again, multiply things on the outside, but the 3 has to stay separate. There, multiply the outsides, and then multiply the insides. When you do that, once again, now the radicals are not like radicals, so they don't end up being able to combine, so that can stay as my answer. All right, well, that wraps up this lesson. So, once again, please take a moment now, write that summary for me. Anything you found interesting, a technique you're going to use to remember what to do, any connections you've made with another lesson. Just have something down there for me, and then come back ready to continue working on your practice work.